So here we are going to discuss in this recording how to calculate the standard deviation using method number 1. As you can see, the table facilitated this process by creating a column called f open bracket x minus the mean all squared, because you must do that for method number 1. And it went further to begin the process. The first f is 50, the first x is 40, the mean we found it to be 52.02. So then we have 50 open bracket 40 minus 52.02 all squared. That will be how much? So for the first f open bracket x minus mean all squared, we got 7,224.02. Now we've got to do this now for the second interval. The frequency here is 30. The x is 50. And the mean remains the same. So it's 30 open bracket 50 minus 52.02 all squared. So this gave us 122.41. Now we've got to do this for the third interval. The frequency is 10. The x value there is 65. And the mean remains 52.02. $1,684.80. And we've got to do this for the last interval. The frequency is 15. The x value is 87.5. And the mean remains 50.02. That's it, 18,882.45. So that will give us all the f open bracket x minus mean all squared. And then we've got to sum this up. Bear in mind, whenever you see sigma, you have to complete all what is to the right of sigma first. So we needed to calculate all the f open bracket x minus mean all squared. Then we add last. So what we have to add is 7,224.02. 122.41, 1,684.8, and 18,882.45. We've got 27,913.68. That's the total. And this now we have to put this over the sum of f, as you can see in the formula. There it is. So we just worked out the numerator, the denominator. The sum of f, we calculated it to be 105. All right, so therefore we can work out the standard deviation, which of course is the square root of the variance. So we can square root one time. Under the square root sign will be the variance. So the 27,914.68 divided by 105, that will give us the variance. And then we have to square root the variance to get the standard deviation. So the variance is 265.84, and now we've got to square root this to give us the standard deviation using method number 1. 16.30.